For thousands of years, human beings have looked up at the sky and observed points of light moving across the darkness. For a long time, almost everything seemed the same, stars. But some of those points did not behave the same way. They did not remain fixed. They wandered slowly among the constellations. Today, we know that those wanderers were planets. And today, we know something more. Planets are not alone, and they do not move without order. They orbit stars. They are part of organized systems, and they obey the same physical laws throughout the galaxy. Today, we will talk about one of the fundamental concepts in the architecture of the cosmos: planetary systems. This is Quasar Untamed. Let's get started. Everything begins in regions of space where gas and interstellar dust exist. In some cases, these regions form large, visible structures that we call nebulae, true stellar nurseries, where many stars are born at once. However, not all stars are born in spectacular nebulae. Often, smaller and more isolated clouds, invisible to the naked eye, can also give rise to individual stars. When one of these clouds is disturbed, for example, by the shock wave of a nearby supernova, its internal balance is broken. Particles of gas and dust then begin to clump together, not because they fall toward a center. In space there is no up or down, but because as they concentrate, their gravitational attraction increases, allowing more material to join the process. As this central region gains mass, pressure and temperature rise. Thus, a protostar is born, a star in formation, still before igniting its nuclear reactions. Not all of the cloud's material ends up in the star. The gas and dust were already in motion before collapsing. As gravity pulls the material inward, that motion is conserved and forces the matter to organize into a flat disk rotating around the protostar. This disk, known as the protoplanetary disk, is the environment where planets form. It is not a rare phenomenon. It is a natural consequence of the physics of motion. Within the disk, microscopic particles collide and stick together. Over time, millions of years, these accumulations grow, first into rock-sized bodies, then into increasingly larger objects, until they form complete planets. This process is known as accretion. It is remarkably efficient. Today, we have observed young disks around many nearby stars, and in several of them, we can see clear structures indicating that planets are actively forming. Once the star stabilizes and the planets complete their formation, the planetary system tends to adopt a characteristic structure. Inner planets, generally rocky and dense. Outer planets, often gaseous or icy. Moons orbiting these planets, formed through accretion or through gravitational capture. Asteroid belts and regions populated by small bodies. Comets with highly elongated orbits, and a vast amount of minor material, dust, and fragments. All of this remains in a dynamic balance, governed by gravity. In any planetary system, the star is the largest object. Its gravity is the central force that organizes the entire system. That is why we speak of orbits. Each planet follows a stable path because the star's gravitational pull balances its motion. For a long time, we believed that planetary systems were rare. Today, we know the opposite is true. Thanks to missions such as Kepler and TESS, we have discovered that planets are common and that most stars in our galaxy, are accompanied by planets. Some resemble our own in their structure. Others are radically different. Giant planets, orbiting their stars in just days. Worlds covered by oceans. Rocky planets, extremely hot. The diversity is enormous. Earth is one of several planets orbiting the Sun, and the Sun is an ordinary star in a galaxy with hundreds of billions of stars. Our planetary system is only one among billions, an ordinary structure in an extraordinarily vast universe. In summary, a planetary system is the natural result of star formation. It is a direct consequence of the fundamental laws of physics, gravity, and motion. But beyond equations and models, each planetary system is also a natural laboratory for science, an opportunity to study how worlds are born, how atmospheres evolve, and perhaps how the conditions for life may arise in the universe. Thank you for watching, and don't forget to leave a like and subscribe for more cosmic content.